Okay, so let's dive into this scaling hypothesis, shall we?
Yeah.
I mean, what could it mean for the future of AI? You send over those excerpts from Gwern.net,
Mhm.
and it really seems like this theory is causing a stir.
Yeah, what's really got everyone buzzing is this idea that, you know, AGI, artificial general intelligence,
Right.
might be simpler than we thought.
Yeah, I mean, it's almost like th the key to uh, unlocking superintelligence isn't about inventing some crazy new algorithm.
Right.
It's just taking what we already have
hmm
and just, like, making it bigger.
Like, think of it this way. If you want a more powerful computer,
Right.
you don't necessarily need to invent, a whole new processor.
Yeah.
Sometimes you can just add more processing power to an existing design.
Yeah.
And the scaling hypothesis is saying something similar might be true for intelligence.
So instead of getting all caught up in these complex algorithms, maybe we should be focusing on scaling up those neural networks we already have
hmm
and just feeding them tons of data.
That's the gist, yeah. And what's really interesting is that this isn't just some theory in a vacuum.
Right.
We're already seeing evidence of this with models like GPT-3.
GPT-3, right. Everyone's talking about it.
Yeah.
It's writing poetry, generating code.
Yeah.
It's even showing signs of reasoning.
Yeah.
It seems like it's doing things that nobody expected.
Exactly. And what makes GPT-3 even more interesting is that the underlying architecture isn't actually that new or complex.
Okay.
What seems to be driving its power is its sheer scale.
Right.
It's a model with 175 billion parameters,
Wow.
which is kind of like having 175 billion knobs you can tweak to fine-tune how the model processes information.
That's a lot of knobs. Okay, so even if bigger is better, doesn't that mean training these huge models would be, like, super expensive?
Yeah, it's true that training a model like GPT-3 can cost millions of dollars,
Right.
but the cost of training is often offset by the model's versatility. Because it's trained on such a massive data set, GPT-3 can be adapted to perform all sorts of tasks without needing to be retrained from scratch.
So it's like a big initial investment, but then you can reuse it for a bunch of different things.
Exactly. And what's
Yeah.
even more exciting is that as these models scale up,
Right.
they don't just become more powerful,
Right.
they also become more stable.
Yep.
They get better at generalizing to new information, and they even start to exhibit emergent properties.
Hold on. Emergent properties. What does that even mean when we're talking AI?
So imagine you've got a simple neural network designed to recognize images of cats.
Okay.
You train it on thousands of cat pictures,
Yeah.
and it gets pretty good at its job.
Right.
But then as you scale up the model and train it on millions of images, not just cats,
Right.
something amazing happens.
Okay.
It starts to develop a much deeper understanding of visual concepts.
Okay.
And it might even be able to recognize different breeds of cats that it's never even seen before. And that's an example of an emergent property.
So it's like it's learning more than just how to identify a cat.
Right.
It's developing a more general understanding of what makes a cat a cat.
Exactly. And this brings us to another important concept, meta-learning.
Yeah.
As these models scale up,
Right.
they develop this ability to learn new tasks with just a few examples,
Right.
much like humans do.
That sounds like a superpower. How does meta learning actually work? Can you give like an example that our listeners can relate to?
Imagine you're learning a new language.
Okay.
You start by memorizing vocab and grammar rules.
Right. Right.
But as you become more fluent,
yeah.
you start to pick up on these subtle nuances and patterns that you weren't explicitly taught.
Right.
You understand idioms, you
Yep.
can make jokes, you can even write poetry in that language.
Yeah.
And that's kind of what's happening with these large language models.
Okay.
They're learning to understand the underlying structure of
Yep.
language,
Right.
which lets them do tasks they weren't specifically trained for.
So by training on these massive data sets, these models are being forced to develop a deeper understanding of the world.
Yeah, and it ties into this other interesting idea. Neural nets are inherently lazy.
Okay.
They'll find the easiest solution to a problem unless you push them with larger data sets and more challenging tasks.
So it's like they need a challenge to really unlock their potential.
Exactly. And what's counterintuitive is that harder problems,
Right.
when scaled up,
Yeah.
actually become easier for these models to solve.
Wow, that's pretty mind-blowing.
Yeah.
It really challenges like our assumptions about how learning and intelligence work.
It does.
Yeah.
Makes you wonder if we've been approaching AI research the wrong way.
Yeah, like if scaling up is the real key here,
Mm-hmm.
where does that leave all the research that's focused on those super intricate algorithms? I mean,
Right.
is that all just a dead end?
Right. It raises some big questions about the future direction of AI.
Yeah.
I mean, if the scaling hypothesis is true,
Right.
it could mean that we've been, way too focused on algorithms and
Uh-huh.
we've underestimated just how powerful raw computational scale and data can be.
Well, and you mentioned before that this whole idea of scaling isn't like brand new.
Right.
I mean, it
Yeah.
has like some pretty deep roots in the history of AI, right?
Oh, absolutely. The scaling hypothesis has this fascinating lineage
Okay.
that goes all the way back to the pioneers of connectionism,
Okay.
the folks who laid the groundwork for artificial neural networks.
Right.
People like Hans Moravec back in the 80s were already saying that AI progress would be driven mostly by the growth of computing power.
Wow. That's pretty amazing.
And the crazy thing is, those predictions have been pretty accurate.
It's incredible how some of those early thinkers were so ahead of their time.
Yeah.
But you also mentioned something about doubters earlier. Not everyone's convinced about this whole, just scaling up thing, right?
Oh, of course. Anytime you've got a new paradigm, you're going to have skeptics.
Right.
And the scaling hypothesis is no different.
Yeah.
Some critics argue that scaling alone won't be enough to get us to real intelligence.
Okay.
They think we need more sophisticated architectures or
Yes.
algorithms
Okay.
to really capture the nuances of how humans think.
Yeah. Yeah, so it's not just about making things bigger.
Mm-hmm.
It's also about figuring out how to make them like smarter
Right.
in a way that's closer to human intelligence.
Yeah, that's a big part of the debate.
Okay.
And it's worth noting that even the people who are, really into scaling, they
Right.
don't say it's a magic bullet.
Right.
They acknowledge that we'll probably need to make advances in algorithms and architectures too.
Okay.
But they still argue that scaling is going to be the main driver of progress,
Yeah.
at least for the foreseeable future.
So it sounds like the AI community is a little divided on this one.
You could say that.
But the success of GPT-3, I mean, that's got to be giving the scaling hypothesis some serious momentum, right?
Oh, yeah. There's no question that GPT-3 has really shaken things up.
Right.
And it's made people take the scaling hypothesis a lot more seriously.
Yeah.
I mean, its ability to do these tasks that it wasn't specifically trained for,
Right.
that's a pretty compelling argument.
Right.
It suggests that as these models get bigger, they develop this more generalized understanding of the world,
All right.
which lets them adapt to new situations and solve problems they've never seen before.
Okay, so let's play this out.
Mm.
If scaling really is the future of AI,
Yeah.
are we just going to keep building like bigger and bigger models until like we eventually get to AGI?
Mm-hmm.
Is that the end game here?
It's definitely a possibility,
Right.
and it's a scenario that, both excites and worries people. Right.
The idea of creating a super intelligent AI just through sheer scale, I mean, that's pretty tantalizing.
Yeah.
But it also brings up all these ethical and philosophical questions
Oh,
about,
yeah.
How do we control and align these incredibly powerful systems?
Right. It's like we're opening Pandora's box.
Yeah.
We might unleash something amazing,
Right.
but could also, spin out of control.
Exactly. And that's why it's so important to have these conversations now.
Yeah.
Before we get too far down this road,
Right.
we need to think carefully about the potential consequences of scaling
Yeah.
and develop safeguards to make sure that AI is used for good.
Right. Right. It sounds like we're at this pivotal moment in AI development.
I think so.
It's exciting, but also kind of unnerving.
Yeah.
We're basically venturing into uncharted territory.
Yeah, it's a great way to put it. We're like explorers setting sail for a new world.
Knowing that the journey is going to be, full of challenges and risks,
Right.
but also, potentially incredible discoveries.
Yeah, and just like back in the age of exploration,
Mm-hmm.
it seems like there's a bit of a race going on, right?
Yeah.
With all these different AI labs competing to build the biggest and most powerful models.
Yeah, there's definitely a competitive spirit.
Yeah.
You've got organizations like OpenAI.
Right.
They're all in on the scaling approach,
Right.
pushing the boundaries of model size with projects like GPT-3.
Right.
And then you've got other labs like DeepMind and Google Brain.
Right.
They're also pursuing scaling,
Mm-hmm.
but they're doing it a little differently.
Okay.
They're looking at ways to combine scaling with insights from neuroscience and cognitive science
Okay.
to develop models that are that are not just bigger,
Right.
but also more intelligent in a way that's more like how humans think.
So it's like there are multiple paths up this mountain of AI development,
Hmm.
and each path has its own challenges and
Yeah.
opportunities.
Absolutely.
But the goal is the same, right?
Yeah.
To get to the top
Yeah.
and unlock the potential of AGI.
Exactly. And what's so interesting is that the scaling hypothesis is making us rethink our assumptions about what that summit might actually look like.
Yeah.
It's making us consider the possibility that intelligence itself might just be an emergent property of scale, something that just arises naturally as we build systems that can process and understand information at this massive level.
So instead of trying to like program intelligence into machines, maybe we just need to create the right conditions for intelligence to emerge on its own.
That's the intriguing idea at the heart of the scaling hypothesis, and and it has these profound implications, not just for the future of AI, right?
But for how we understand intelligence itself.
This has been an incredible deep dive so far.
Yeah.
But I feel like we've only just scratched the surface.
We have. There's so much more to explore.
Yeah.
But maybe this is a good place to pause and let all this information sink in.
Yeah, this is a lot to process.
Yeah.
But I am really eager to continue our exploration.
Okay.
So what can our listener expect in the final part of this deep dive?
Well, in the next part, we're going to delve into some of the potential implications of the scaling hypothesis.
Okay.
We'll explore what the future might hold as we keep scaling up these models.
Right.
We'll talk about the potential benefits and risks of this technology.
Right.
And we'll think about what steps we can take to make sure that AI is developed and used responsibly.
So we've spent a lot of time in the last two parts digging into this scaling hypothesis.
Yeah.
This idea that, the path to AGI might be as simple as more computing power, more data.
Right.
It's fascinating, but I got to say, it's also raised like a ton of questions for me.
That's understandable. The scaling hypothesis is definitely exciting, but it can be a bit daunting too.
Right.
It challenges how we think about intelligence
Yeah.
and makes us really confront this idea of machines that might become more capable than humans.
Exactly. Like if just making these neural networks bigger leads to these huge breakthroughs.
Right.
What does that even mean for the future of AI research?
It's a big question, and it's causing a lot of debate in the AI community. You've got organizations like OpenAI, they're all in on scaling.
Mm-hmm.
They're putting their resources into building these massive models like GPT-3.
Right.
They believe that scaling is the most promising way to get to AGI.
And they've got some pretty impressive results to back that up.
They do. GPT-3 is already doing things that people thought were, years or even decades away.
Exactly. But it's not just about blindly building bigger models.
Right.
OpenAI is also doing a lot of research to understand how scaling works and to develop safeguards.
Yeah.
To make sure these powerful systems are aligned with human values.
Exactly.
But you mentioned before that not everyone's totally convinced about this scaling first approach.
Right. There are other labs like DeepMind and Google Brain. While they've seen the impressive results from scaling, they think getting to true AGI will require more than just brute force computation. They're taking inspiration from neuroscience and cognitive science to develop algorithms and architectures that are more like how the human brain works.
So it's not just a race to build the biggest model.
Right.
It's also this quest to understand what intelligence really is and to find the best way to recreate it in machines.
That's a great way to put it. It's like we've got these two different schools of thought, each with their own strengths and weaknesses. And the truth is, both approaches will probably be important for developing AGI.
Right.
We might need to combine the power of scaling with the elegance and efficiency of more biologically inspired algorithms.
It's like we're trying to solve this giant jigsaw puzzle.
Yeah.
And we've got these two different sets of pieces.
Right.
One's all about scale, the other's about, taking cues from biology, and we'll probably need both to complete the picture.
I like that analogy, and it highlights how important collaboration is. We need to be sharing knowledge, comparing different approaches, and working together to make sure AI is developed responsibly.
Yeah, it feels like we're entering this whole new era of AI research, one that's both like super exciting and a little bit uncertain.
For sure.
We have this incredible potential to make breakthroughs that could totally change the world,
Right.
but we also got to make sure that we're using this technology wisely.
That's a crucial point, the scaling hypothesis, regardless of whether it gets us to AGI or not. It shows us that we're in a time of really rapid technological advancement.
Yeah.
And with that comes this responsibility to think about the ethics of it all
Right.
and make sure AI is aligned with human values.
So for our listener who's been, following along with us on this deep dive, what's the most important thing to remember as we move forward into this unknown territory?
I think the key takeaway is that the future of AI is going to be shaped by this tension between scaling and coming up with new algorithms. And that future is being written right now
Yeah.
by researchers, engineers, policymakers, and everyday people.
It's like we're all like characters in a sci-fi novel, and
Yeah.
choices we make now are going to determine how the story unfolds.
Exactly. So stay informed, stay engaged, and keep asking those tough questions about AI because the future isn't something that just happens to us. It's something we create together.
Well, on that note, I think we've done a pretty good job unpacking this scaling hypothesis.
I think so.
But like you said, there's always more to learn,
Always.
and I have a feeling this is something we'll be coming back to
Yeah.
as AI continues to evolve.
Absolutely. This deep dive was just the beginning. I encourage our listener to keep exploring this topic, to really dig into the research and form their own opinions about the future of AI.
Because ultimately, the future of AI isn't going to be decided by a few experts in a lab.
Right.
It's going to be shaped by all of us.
And that's what makes this such an exciting and important time to be alive.
Yeah.
We're witnessing the beginning of something totally new.
Right.
Something that has the potential to change our world in ways we can't even imagine.
So until our next deep dive, keep exploring, keep questioning, and keep imagining what's possible.
Because the future of AI is out there waiting to be discovered.